They're not quite the same. I've had a number of people email me say, gee, you really got it right. We didn't get it right at all. There's no crossbar here. And it's brighter on one side. We're not brighter on one side there. So what's going on? Well, here's one way to understand what's going on. The camera for the movie Interstellar is near the plane of the disk. And so that's what it looks like in Interstellar. But we're going to move the camera up to the North Pole and see what happens. It's pretty obvious. You lose the crossbar. And then you blur things out because the radio astronomers don't have very good angular resolution.
This fascinating concept arises from Einstein's theory of relativity and is one of the most intriguing phenomena in physics. Time dilation occurs when time appears to move at different rates, depending on the observer's relative motion or gravity. In the movie Interstellar, we saw an extreme example of time dilation when the crew travelled near a supermassive black hole. Due to the intense gravity, time moved much slower for them than it did for people on Earth. When they returned, they had aged much less than the people they left behind. Time dilation is a concept that challenges our intuition about the nature of time itself. It has been confirmed by countless experiments and observations, and it plays a critical role in modern physics.
What does the fourth dimension look like? Christopher Nolan's Interstellar has one of the best movie representations of the fourth dimension. One simple way to attempt this is to see what happens when you mathematically render a square into the fourth dimension. A square is a two-dimensional shape. In the third dimension, you get a cube. And in the fourth dimension, you get a tesseract.
You mean like this?
No. This is the closest representation we have to a tesseract. Now, we cannot comprehend or even imagine what a real tesseract looks like because we are three-dimensional beings, but our eyes perceive things two-dimensional. Theoretically, there is a fifth and sixth dimension and so on. So for now, we can only wonder.
Wormholes are some of the most exotic objects hypothesized to exist in the universe. They are the shortcuts through space-times between two locations, connected by a bridge called a wormhole's throat, featuring an entrance and an exit. The idea of wormholes was first proposed by Ludwig Flamm in 1916 and later expanded upon by Albert Einstein and his colleague Nathan Rosen in 1935. The concept originates from Einstein's general relativity. According to it, space-time can be curved, and a wormhole is a place where the curvature of space-time is so extreme that it creates a tunnel-like structure. These bridges can connect distant points within the same universe, as well as between different universes. However, no traversable wormhole has been found to date. For more videos of Cosmos in a Minute, follow the secrets of the universe.